Hi everyone, we're going to look at how to take a sequence and write an explicit formula for it if it is a geometric sequence. So we know these are going to be geometric because there's a common factor that multiplies each term to give you the next term. This would be times 4 every single time, which is why it's geometric. So the reference sheet has this formula, a of n equals a1 times r to the n minus 1. But I think that this formula is a little bit easier to use, y equals a times b to the x, where this is the y-intercept, or a0, and then b is what you're multiplying by, which is the same thing as r. We're just using the y-intercept instead of the first term. Either way, it does work. I'm going to show you both, though, just so you can kind of see both ways. So this is times 4 every time, and the first term is 20, second term is 80, etc. Third term is 320, fourth, fifth, and 6. So using the one from the reference sheet, it would just be an equals 20, the first term, times 4 to the n minus 1. That would be it. That's all you'd have to do. Or we could work backwards. We could find the y-intercept. What would it be at 0? So something times 4 is 20, and that would just be 5. So another way to write this would be an equals 5 times 4 to the n, which is like this formula that we use for exponential functions. These are both equivalent because you could rearrange the first one by doing 20 times 4 to the n times 4 to the negative 1, and then multiplying 20 times 4 to the negative 1 using your commutative property. You can do those two first and then do 4 to the n later. This would be 20 times 1 over 4 times 4 to the n, which is 5 times 4 to the n. So it's all exactly the same thing. Either way, whatever makes more sense to you, use that because they are going to be equivalent. For the next one, very similar. We could start with, this is our first term, second term, third term, etc. This is going to be times negative 5 every time. See how it's changing the signs there every time, so times negative 5. So that would be, if you want to use the one from the reference sheet, it would be the first term times negative 5 to the n minus 1. Or we could figure out what would come first, what would come before the 5 over here for the y-intercept. So something times negative 5 is 5, which would be negative 1 if you use division and work backwards here. So you could write it as an equals negative 1 times negative 5 to the n. These both represent the same thing. As we showed up above, it's the same amount of work really to show these are both equivalent. For the last one here, very similar. This starts at the first term of negative 4, so our formula would be negative 4, and then we're multiplying by negative 4 every time, so negative 4 times negative 4 to the n minus 1 would be one way to write it. Or if that's the first term, we could work backwards, find the 0th term, the y-intercept. Something times negative 4 is negative 4, it's got to be 1. So you could write it as an equals 1 times negative 4 to the n, which of course is just negative 4 to the n, like that. So either way you want to write it, they are both equivalent, and that's how we write an explicit formula for a geometric sequence.